Well, I thought I'd make another video because I've been doing some thinking about this. And you know the problem with motors? When you have a motor and you're using a ferrite core, the problem is that it causes lag. You know, you get your motor and it's spinning. The magnet is running past the coil. Obviously, that's what we call the drag, where it's generating a coil. It's inducing a current in the coil. Now, when you take current from the coil, that induces a reverse drag, which slows the motor or the magnet down. Well, this is why I'm looking at a way to send energy into the magnetite and redirect the magnetic field so that as the magnet moves, it believes that it's got the same amount of it's got the same amount of attraction in all the areas, you know, whether it's over the coil or it's at the side of the coil. That's what I'm trying to sort out. That's what I'm trying to work out. Because if we can get it so that it's feeling more attracted to the ferrite or the graphite, I should say, at the sides of the coil than it is over the coil, then in theory we should be able to generate energy without having that braking effect. And so I'm thinking, well, obviously, whenever you induce a current in any material, whenever you induce a current in any circuit, obviously the reason why a motor works is because you send power through the coil and it pushes the magnet away from it. Well, obviously the reverse is true. When the magnet is running towards the coil, it's inducing a current, a voltage in the coil. So therefore you would expect, obviously, that it's going to want to slow down, because if it didn't want to slow down when it's inducing this current and you're taking power from the coil, then in theory, if that didn't work, then you wouldn't be able to make a motor spin by applying a voltage and a current to the coil, because you would also have no momentum if the coil wasn't able to move the magnet, if you see what I'm getting at. So, right. So, basically what I'm trying to do is find a way to induce the current, the voltage and the current in the coil, but without having this braking effect. Now, everyone says, oh, you can't do that. Well, obviously, maybe you can. I mean, how does a car engine work? It works through timing, doesn't it? You've got an ignition, it fires the sparking plug, and the sparking plug ignites the petrol, and it pushes the piston down. Now, if we can get the timing and the frequency right, so that the induced current in the coil, if there's a slight lag, you know, because with inductance you have lag. You know, any magnetic material, it has a frequency. It has what's called reactance. Now, if I've got this magnetite powder there, and I've got graphite powder here, and I'm thinking, well, if we can mix the two, obviously the magnetite is magnetic, the graphite is non-magnetic, and I don't understand what happened with this stuff, but because I'll tell you what happened, I'll just pause a minute. Right, I observed something very, very strange. A friend of mine gave me this. This is a solid piece of graphite. It's a solid bar of graphite. Now, I'm going to ask you a question. I would like you to comment, because I want to find an answer to this question. I placed some magnets on this graphite bar. Now, the graphite has a strange effect with magnetism. he has a tendency to want to push or give levitation to the magnets. I am not going to do that on this video. I'll explain why. Because every single time that I put my magnets on this piece of graphite and attempt levitation, a magnet will fly off and hit another magnet and break. Now, how many times has that happened to you? That you've been using a piece of graphite and you've had your magnet on the graphite and it's jumped off and hit another magnet and shattered? Because I have got 3 broken magnets here. Well, they're not actually with me right now, they're in the other room. But I have 3 broken magnets, and all 3 of them broke when I was attempting a levitation on this piece of graphite. That doesn't make any sense, because I've got magnets that have jumped and hit each other and bumped into each other when I haven't been using this, and all of them have survived without a scratch. There's something weird going on with this graphite. It's something to do with the properties of graphite that I don't understand it. I just do not understand what is going on. All I can say is that, well, I will get one magnet. Hang on a minute. Because I can't go wrong with one magnet, because it's not going to bump into anything. But it actually does seem to float very lightly on the graphite, much lighter than it would if it was on a piece of paper. Very, very light. I'll just show you what I mean. It's like, there's very, obviously graphite's a lubricant. Well, we all know that. It's a lubricant. We know that. But it does have levitational properties. And when I tap it, it's like it's not quite on the graphite. So, what I'm basically explaining here is that all 3 of those magnets that broke were all broken after being in contact with the graphite. And I don't know why that happens. Has that happened to you? Because I'd really like to know. And I'm really trying to figure out why it's happening. Why it's breaking the magnets when it's near the graphite and it's not happening otherwise. Because that just doesn't make sense. I mean, the chances of that, what are the chances of that? Anyway, so I'm thinking, if I mix some of the graphite powder, right, with some of the magnetite powder, and put a mixture of it in here, I'm going to gain 2 things, obviously. One is that the graphite is going to act as a bit of a lubricant, and obviously it's not magnetic, so it's going to fill the areas that are not polarized by the magnet. So it will help a little bit with the polarization, simply because the polarized areas will be a little bit lubricated because the graphite's effect, and it will help me to get them more polarized. And I'm also thinking that maybe that levitation effect that we observe with with graphite, maybe that levitation effect with speed as the magnets are spinning around, maybe that will give us some additional properties in the way the magnetic field behaves. It's all experimental. It's all purely theoretical and experimental, and there's a whole bunch of unknowns, and I'm just trying to figure it out. I just don't understand why my magnets kept breaking. And that one's got a chip in it, you can see. that's what's been, actually I think that's one I repaired, I think. I can't be sure. Yeah, I repaired that one because it's got red paint on it, because it had a chip on it, and that one actually got damaged on that graphite before. But, so, if, yeah, anyway, I just want to know, this video is 10 minutes already, so I'm trying to keep them short. So if anyone wants to comment on this, because I really do want to know if anybody else has experienced some similar peculiarities with graphite, and this is magnetite in here. And yeah, this will be part 4, so if you haven't watched the earlier parts, I suggest you go back to the beginning and watch part 1, 2 and 3 about what I'm trying to do here, because I've already explained that. Right, okay, thank you for watching.